Okay. Fine. So welcome back, guys. So welcome back to the session 3 of the question paper discussion. Okay. So yesterday we stopped with the question, like the question number was 95, right? So we stopped with 95. Like we need to solve this 95th question, no? Okay. So a metal plate of mass, like I have given the hint of the question, no, how to solve. Like we'll solve in this question, okay? Like in this class we'll solve it. Like a metal plate of mass. So metal plate of mass 50 gram. Okay, 50 gram. I need to convert it into kg, right? 50 by 1000. Am I correct? Yeah. So 0 cancel and it is 0.05 kg. Next, heated to a temperature of 200 degrees Celsius. Keep this one, 200 degrees Celsius, that is T1 is equals to 200 degree Celsius. Okay. Then immersed like so what they are saying is they have taken a box or something else, in that water is there. Okay, water is there which is at 20 degree Celsius. Okay. Now this metal plate, no, they have immersed. So this was 200 degree Celsius. This has been immersed in the water now. So what is the water? 150 gram. So W is equals to 150 gram. I need to convert it into again kg, right? So 150 divided by 1000. 0 cancel and then 0.15 kg. Next thing, so temperature is 20 degree Celsius. So T2 is equals to 20 degree Celsius. If the temperature of water is 50 degree Celsius at equilibrium. So at equilibrium they are saying that it is 50 degree Celsius. So I will take T is equals to 50 degree Celsius. Okay. Then the specific heat capacity of metal. They are asking what is the specific heat capacity of the metal. Like so what we can understand here, we can understand that when hot water is there and cold water is there, if I mix both of them, what will happen? It will become a normal water, no? The same case. So hot metal is there, that is 200 degrees Celsius, and the water is there, that is 20 degrees Celsius. When we keep both of them, the equilibrium temperature was 50 degrees Celsius, they are saying, right? No. So what happens here? Heat gained and heat loss has been taken place. I can say that heat gain equals to heat loss, no? That is the thing we know. By this we can derive the formula, that is M1C1 delta T is equals to M2C2 delta T. Okay. From this I need to find the specific heat capacity of metal. But what about the heat, like water? They have given here. It is 4200 joule per kg Kelvin. Okay. So mass of this 0.05 into C1 I need to find. I will keep as it is. This delta T is T minus, that is T1 minus T. T1 minus T is equals to mass of the water is 0.15 kg C2, that is 4200, and delta T here is T minus T2. Okay. So 0.05 C1. What is T1 here? 200 degrees Celsius. T is 50. So 200 minus 50 is 150. Okay. Next 0.15 into 4200. This is T. What is T here? 50. T2 is 20. So 50 minus 20 is 30. Okay. So from this I can find C1, no? C1 is equals to 0.15 into 4200 into 30 by 150 into 0.05. Right. So from this I can take out the points, no, 15 into 4200 into 30 by 150 into 5 multiplied by 100 by divided by 100. So I can get 15 by 5 as it is. So I can, if I solve this one, I'll get the answer for C1, right? Yeah. Okay, we'll go for the next question, guys. Hope it's clear. What is the answer given? Yeah, 2520 is the answer. Next question, question number 96. Okay. Yes. So take a look at this question. What they are saying here, a pendulum clock gains 6 seconds per day, 6 seconds per day when the temperature is 296 Kelvin. Okay, 6 seconds per day means it has been increased, right? I'll take T1 is equals to plus 6 at 296 Kelvin. Okay, and gains 9 seconds per day when temperature is 291 Kelvin. Okay, T2 is equals to plus 9 seconds at 291 Kelvin. The temperature at which the pendulum clock loses 12 seconds per day. What they are saying is, like, time has been lost, no, like 12 seconds minus 12, no. I need to find the temperature here. At what temperature I need to find? Like we know that, no, like time is equals to 2 pi root over L by G, right? So we know the concept. When temperature increases, length increases, right? Length increases. So when the length increases, the time also increases. So when temperature decreases, length, it will be shortened and the time also will be more. It gains, right? That's the concept we'll use here. So L is equals to L naught into 1 plus alpha delta T. Okay, by these two formulas, I can find that, I can say that T is equals to, like T is equals to minus of minus delta T. Okay, by these two formulas, like equation number 1 and equation number 2. If I analyze, I'll get the formula T is equals to minus T minus delta T. Okay, so now the ratios I can take, no, ratios. So temperature, like time plus 6 and time plus 9 is given. Here I can write T1 minus T2 by temperature 1 minus temperature, that I'll keep as it is, T2, okay, is equals to T1 minus, I need to find the unknown temperature, right, T2. Okay, let's make it simple. Temperature we know, that is T1 minus T2 temperature also we know. T1 temperature, T2 temperature, T1, T2 divide by time T1 minus T2 is equals to temperature T1 minus Tx, I will take unknown temperature, okay, divide by T1 minus T, the given time here. Okay, now I can find what is Tx. So what is T1 here? 296 minus T2 is 291 divided by the time 6 minus 9 is equals to 296 minus Tx divided by, and the time given is 6 minus of minus 12, right? So minus of minus 12. Okay, so what I'll get? 5 by minus V is equals to 296 minus Tx divided by 18. So 1 sir is 6 sir, right? So what I'll get? Minus 30 is equals to 296 minus Tx. So multiply minus in both sides. I'll get 30 is equals to Tx minus 296. So Tx will be equals to the unknown temperature is equals to what I'll get 326 Kelvin. What is the answer given? Yeah, 326 Kelvin is the answer. Okay. Can we go for next question? Yes, you can take down. Take a screenshot of this and we'll go for the next question. Okay. Yeah, fine. So efficiency of Carnot's engine is 25%. I'll write the efficiency 25%. If the absolute temperature of the sink is increased by 10%, then the efficiency of engine. So what is the formula? We know for efficiency of the Carnot engine, it is equals to 1 minus Tc by Th, right. So what is the efficiency given? 25%, that is 0.25 is equals to 1 minus Tc by Th. Now we know the equation. I'll keep this equation as equation number 1. Now they have said that absolute temperature of the sink is increased by 10%. Okay. So wait a minute. Tc by Th is equals to 1 minus 0.25. I'll get Tc is equals to 0.75 Th times Th. I'll keep this one. Now they have said that 10% has been increased, right? In this 10% has been increased. 10% increased means 100%, no? Like initially we will calculate the percentage in terms of 100. So 10% increased means 110 divided by 100, which is nothing but 1.1 percentage has been increased. Okay, so Tc is equals to, okay, Tc or T dash C, like new one I'll take. Okay, absolute temperature has been increased. T dash C is equals to 1.1 into 0.75 Th times Th. Okay, now I can say that T dash C by Th is equals to 1.1 into 0.75. What I'll get? 11 into 75. 5757. 527. Sorry, 8. No, 825. Am I correct? Yes. Divide by how many zeros? 1, 2, 3. So 0.825. 0.825 is the answer for this one. 0.825. So I'll keep as it is. Now the efficiency I need to find. New efficiency. Eta dash is equals to 1 minus T dash C by Th. Okay. We know that T dash by T is equals to 0.825. So 1 minus 0.825. 825. This will be my new efficiency, right? Yes, you can take a note. Okay, we'll go for next question. Fine. So what is the next question? Is given. Okay. specific heat capacity of 1 mole of water is, okay, I need to find the specific heat capacity of 1 mole of water, right? So in terms of R I need to find, right? So what is the specific heat capacity of water? It is C is equals to, yeah, so 18 calories per mole Kelvin. Okay, so I need to convert it into the SI unit, that is joules. No, in joules I need to convert. So what I can say, this is 18 into 4.2, approximately 4.2. R will take 4.18 is the exact value, will take approximately 2. Okay, now I need to get it in terms of R. No, okay, first I will multiply this 18 into 42, so 6 1 3 plus 8 32 2 3 7 6 5 7, right, 75.6. okay, so C is equals to X into R. In terms of R I need to get it, so C by R is equals to X. This is the thing we will get. So see, what is C here? 75.6. What is R? The value of R, real gas constant, 8.314, right? 8.314. So approximately we will take 8.32, no, 8.32. Okay, we will divide it now. So 75.7560 divided by 823. I will get the value of X approximately as 9R. Okay, this is the thing. So specific heat capacity of water has been given, 1 mole of water, that is 18 calories per mole Kelvin. I need to convert it into joules, so into 4.2 I have taken. Okay, that is approximately 4.18, no, so we will take approximately 4.2. So 75.6 will get. So in terms of R they have asked, like universal gas constant. So C is equals to X times R, no. So if I divide C by R, I will get what is the value of the answer in terms of R. Okay, take a note of. We will go for the next question. In the meantime, you can see the question also. What is the given question there? Can we go for the next question? Yes. Fine. In a medium, a source produce 60 crust and 60 trough in time of 0.2 seconds. If the distance between the crust and trough, the crust and its adjacent trough is 100 centimeter, then the speed of a sound in a medium, I need to find what is the speed. So what I have given, 60 crusts and 60 troughs. It means one complete wave, right? One complete wave. So they have asked, they have given the distance between the crust and the trough, right? So that is 100 centimeter. So when we take it into meter, it is 1 meter, right? Yeah. So This means lambda by 2 is equals to 1 meter. So lambda will be equals to 2 meter, the wavelength. Now the frequency, the wavelength divided by the time. No, where is the time given? 0.2 seconds. No, yeah, okay. Now the speed I need to find. What is the speed formula? Yes, it is V is equals to frequency into wavelength. Listen guys, see here, see this one, number of waves, no, it is 60. So 60 by 0.2, okay, not 2, it is 60 by 0.2. So 600 divided by 2 is equals to 300. Okay, so the speed I need to find. Speed is nothing but frequency into the length, wavelength, that is lambda. So 300 into 0. Yeah, 2, that is 600. Yeah, we got the answer as 600 meter per second. Fine. We'll go for the next question. Okay. Take a look of this question. An observer moves towards a source at a rest with a speed of 25% of the sound, of the speed of the sound in air. If the frequency of the sound emitted by source is 200 Hz, then the frequency of sound heard by the observer. For this, direct formula is there, no? Take a look of the question carefully. Okay, see, we'll write the given things here. Given things. So observer moves towards the source. So velocity of the source equals to 0. Speed is 25% of the speed of the sound, like with the speed of, so observer, like this is velocity of the source, right? Vs is equals to 0. Observer is equals to 25% of velocity of air. If the frequency of the sound emitted is 200 Hz, then the frequency of sound heard, so f is equals to, like f dash is equals to f into v plus v naught by v. Okay, this is the direct formula. Like you can solve the given terms, like use the given terms there and solve it. So v I'll keep as it is, v naught as 25, that is 0.25 v, right, by v. So the frequency given is 200 Hz, no? So I can substitute there as it is, no? See, 200, right, 200 into, what is v? Okay, I'll keep as it is, that is frequency of the air, plus v naught observer, that is 0.25 times of v by v. So 200 into 1.25 v by v get cancelled, no? So 2 into 125, which is nothing but 250 Hz is the given in the option. Yes, third option, 250 Hz. Vinay, hi Vinay. Bunny Borgum. See ma, like you need to practice more number of questions, okay? Like if you practice the same pattern of n number of questions, like suppose you take a look of the question, similar question you need to practice like 15 to 20 questions, okay? Then you can get an idea, then you can able to solve, okay? No need to worry. Okay, we'll go for the next question, guys. Okay. Okay. So a convex lens produces clear image when placed at two positions between an image and a screen. Then that are 1 meter apart. 1 meter apart. If the distance between the two positions of a lens at which clear image are formed is 20 centimeter, then the focal length of a lens, easy no, like that formula is there no, f is equals to d square minus d square by 4d, right? What is the distance given? That is 20 centimeter, like two position of a lens distance, that is 20 square minus this one is 1 meter, no? I need to convert it into, wait a minute, before that we will convert everything into the units. So 20 centimeter is there, I will keep as it is. In option what they have given? Centimeters, okay fine. This one I will convert it into 1 meter to 100 centimeter. Now you can apply the formula, f is equals to d square minus d square by 4d. Okay. Now when I place two positions between the object and the screen, okay, so d is the distance between object and the screen, then position of two lens, small d, so 100 square minus 20 square divided by 4 into 100. What is 100 square? It is 10,000 minus 20 square is 400, right? Divide by 400 again. So 10,000 minus 400 is 9600 divided by 400. Two zeros cancelled, and then 1, 2, 4, 24. Yeah, we got 24, right? 24 is the answer. Okay, I'll show the next question. You can take a look of this question and we'll solve in the next class, okay? So distance between the object and eyepiece of an astronomical telescope when the final image forms at infinity is 62 centimeter. If the magnification of a telescope is 30, the focal length of the objective and eyepiece respectively are, okay? So take a look of the question, we'll solve in the next class, okay?